Oh, she's new.
Yes.
That was MIG welding aluminum with everything wrong. So what we're going to try to do today is dial some of that in and talk about things that make a lot of difference. Gun angle makes a lot of difference. Stick out makes a lot of difference. Argon flow makes a lot of difference, and it makes way more difference than it does with MIG welding steel. It's not necessarily harder using a spool gun to MIG weld aluminum than MIG welding steel is. It just can be, because everything makes more of a difference. Little things mean a lot when it comes to spool gun. But most people that have MIG welded aluminum with a spool gun would agree with me on this. It can be a little more finicky. It can be a lot more finicky, and a lot of it depends on the welding machine and the spool gun and how things are set up. I've used a few different brands, actually several different brands. Some of them were really finicky. Some of them I would have to tell people, look, start off with the wire feed speed way high, because if you didn't, as soon as you hit the trigger, it would just pop and just fuse to the contact tip, and then you went through 4 or 5 tips before you ever got the settings right. The setup I'm using today is not the smoothest I've ever run as far as the mechanisms and everything, but it was very forgiving. I haven't gone through a tip yet. Let's run a quick T-joint here on 1/8 inch thick aluminum, and then we'll talk about setting the spool gun up and some other issues. Just like with TIG welding, you can see a little cleaning path just outside the toes of the weld. That works best with a push angle, but only if you have enough argon flow and the right stick out length. That's going to vary a little bit with the diameter of wire you're using, the setup you're using, the size nozzle you're using, and things like that. For this setup, 35 to 40 CFH was close. Wasn't perfect, got a little bit of soot, especially on the start, but somewhere around 35 to 40 CFH was close. The way argon flow makes a difference is if you don't have enough, you're going to get soot, because that cleaning action from the reverse polarity, it's kind of like TIG. You get a cleaning action outside the bead, but you won't get that if you don't have enough argon. So you'll get a sooty weld and a dirtier weld. So you need enough argon flow, but the sweet spot is fairly narrow. If you get too much argon flow, it acts a fool. The arc gets really erratic. You get spatter. It acts like you're trying to heat something up while you're trying to blow on it at the same time. And so, you got to get that. You got to get the argon flow balanced where you have cleaning action, but still a smooth arc. And so for this, it's somewhere between 35 and 40. And I don't have it quite dialed in perfect yet, but you could see that cleaning action right next to the bead. I'm still getting a little soot. Gun angle, same thing, makes a big difference. You need a push angle in order to get the best cleaning action. There's times when you have to pull, and we all know that, and you're going to get a sootier weld, and sometimes it's fine and it brushes right off and the weld looks great. But just know that it's preferred to push. Stick out, you need a longer stick out than you do for MIG welding steel. Probably about 3/4 of an inch. And you got to, you have to play with that. If you get too close, you can hear it sputter. It kind of changes from spray to short circuit momentarily. And you can watch little sparks exit the puddle. Not a huge deal, but not ideal. So stick out, a lot of times, if you'll play with it as you're going along, you'll find the sweet spot and you're like, wow, that really smoothed out. We're talking about spray transfer here for aluminum. Primarily, that's what you usually want. And there might be times when you have to weld something thinner, and something really thin, like you need to plug a hole in an aluminum boat and all you got is a spool gun. Wouldn't recommend it. I've seen it done, but you're going to have lower settings there, and it's going to be more like a short circuit transfer, because you're not going to enter spray until you get that voltage up to a certain 19 volts, 19.5, 20. I don't know exactly where the point is. It depends on a lot of different things. Primarily, when you're using a spool gun, you want it to be in spray transfer, and so you're going to get a hum sound, a hiss sound, instead of a bacon crackling sound. If you get that bacon crackling every now and then, you can usually fix it with stick out. With MIG welding steel, there's pretty wide range, and it's still smooth. There's always an optimum. There's always a sweet spot. But steel is way more forgiving than aluminum. Those are 3 main things: gun angle, stick out, argon flow. They all make way more difference on MIG welding aluminum than they do on MIG welding steel. Let's take a look at some pointers. First off, I have undone the steel wire. Took the MIG gun loose from right here, pulled the wire back, made sure to put the wire through the hole on the spool so it doesn't unspool. This is not used for a spool gun. Spool gun's got its own drive motor in it, but gas does flow through here and out through the spool gun. See, the gas is hooked in right here. Well, we're gonna hook the spool gun in here. Okay, look down here, aluminum wire spool gun, 100% argon. That is key. You can't do any good at all with your MIG gas for steel. Don't use 75-25, don't use CO2, strictly argon. There are a couple of other choices. You can use helium argon blends, Stargon AL, things like that, but 100% argon is the most common. And today I believe we're going to be using, let's say we're going to be using a 035 wire. Look at this the same as you would any other MIG chart. I'm going to start off with 1/8, so with 035 wire, I'm all the way on the bottom there, 19.5 volts, 331 inches a minute. We'll see how that goes. I'm guessing we might have to turn the voltage up, but I don't know. First time using the spool gun here. Got a little image here depicting ground clamp goes in the negative. Our electrode pigtail goes in positive for electrode positive. And then the spool gun plugs in where the other MIG gun plugs in. DC EP for MIG aluminum, always. This is the MIG gun port. You can see there's no hole. There's no hole for wire to go through here. Doesn't need it. You got 2 O-rings just like you do on the regular MIG gun. And the gas port holes right there. It's wise to moisten these O-rings before you plug it in. I'm just going to use spit on my finger. Bottom that out. And this plugs in right here. Now come around here. All right, so we want to make sure this is bottomed out, and in order to do that, you want this set screw loose. So I'm going to bottom it out so that makes sure that those O-rings are in the right place. And I'm going to lock that in place. And I'm ready to go. Except for hooking up the argon gas. All right, this is your drive roll, the drive roll right here, and it's typically going to be knurled to feed the soft aluminum, and then it's only got to feed out this far instead of through a 9-foot or a 6-foot gun or whatever. That's the benefit of a spool gun. It's only got to push the aluminum wire from here to the contact tip, so it's less likely to kink up. So you do need to have enough tension on the wire, but not too much. All right, so it's on MIG 2T, and then just voltage and wire feed speed. You can see it goes slow until for a few seconds, and then it speeds up. That's typical for a lot of spool guns. Slow run-in. All right, so that's your tensioner knob here. All of them are going to have some method of tightening up on the wire. Typically, you're going to have a knurled drive roller, but not always. Some of them are U-shaped. And I just want to have enough tension here, but not excessive tension. All right, this has got just a spring-loaded thing here to keep the spool from backlashing. And they're all a little bit different. I've got to run this one down pretty far because the cover fits on here too. So I've got to run this one down to where I have enough threads to get that cover started. But you can see it gives pretty easily there. I want it to have a little tension on it so it doesn't keep spinning. That should be about right.
One great thing about a spool gun, especially when you're working by yourself, is you can hold the part with one hand and tack with the other. If you have never tried to make a living welding, I don't think you can really grasp just how beneficial a spool gun can be. TIG welding might be more fun, stacking dimes might be more fun, but making money is more fun than that. For 1/8 inch and thicker, where a stacked dime appearance isn't mandatory, a spool gun can make you way more money and get the job done way quicker.
Next video, we'll tackle some 1/4 inch. So we're going to have different settings, and then we'll also go uphill on 1/4 inch.